Hello, everyone. Welcome back. Please remember, next week, in a week, you have the final exam. So it's a very good time to start reviewing everything. Review your quizzes, review the midterm. In the final, the questions could be any of those and more, obviously. The exam is comprehensive and include open questions and multiple choice questions. Please review everything. You have time, you have the weekend, and any question, please let us know. You can contact me or contact the TAs, but start reviewing things. Also, please do not forget to submit your assignment. You have an assignment to submit. Please, you have still some time to work, a couple of hours. The assignment is an easy one. You should be able to finish in a couple of hours. Even if you haven't started yet, you still have time to do it and complete it today. But again, any question, please let us know. A common question that I have been receiving, and I would like to share this answer with everyone. You could have access to the questions. Yes, obviously. You can contact the TA if you didn't have access, so you do not know how to access those questions. But yes, you should be able to review those questions. You're going to have access to the question, to your answer, probably not to the correct answers. The correct answers are in the video lectures or the slides. So you could review that there, the correct answers. But for the questions, you have access. So for the assignment, a common question, you have the Blackboard. Basically, what you need to do to complete the assignment is to complete the implementation for the Blackboard with some functionality there. Remember, you have the repository. That is kind of the Blackboard. It's the name that we are using for our class that represent this Blackboard shared memory space. And you have the knowledge source and you have the control. The control, like the professor, the knowledge source, like the student, in the source code that I share with you. Remember, the repository is observable. You already have that relationship. You already have this repository able to be observed. And question number one, you have been asking me, what do you do to connect the view or a panel, whatever is the name of the place in which you are doing the draws with the data? And the answer for that is this guy should be observer. So this one is observing and this one is observable. All the data about dots, all the data about lines should be in the repository. Remember that I showed you this class diagram with those classes, dot, point, whatever name you want to use, and lines. What you should have is in the repository, a data structure, could be a linked list or something similar, a stack for points and another for lines. And then your panel, your view, whatever it is, the thing that it's going to do is to be an observer. And therefore, it's going to be able to access this data. The connection is going to happen between this one and this one, as we reviewed before. So this is number one. The connection between the view and the connection between the data. The data is in the repository. The view should access the data from the repository. Now, the other thing, what happened with the control and the student? What happened with the control and the knowledge source? Something that I mentioned in the previous lecture, something that I have been replying to some emails is, please, you cannot put control or knowledge source as a variables inside of a repository. Because what you're going to tell in the software is that a Blackboard is the owner of a professor or the owner of a student. And that will not make sense semantically. Something that we reviewed before with the smells. It's like, really, the repository is the owner of the ones that are doing the work, do not make sense. In the similar way, do not make sense if you do this inheritance, control or knowledge source inheriting from repository. No, the relationship that you want to have is, number one, using control, use the repository, knowledge source, use the repository. Implementing that is easy because repository is a singleton, remember? So just because repository is a singleton, anyone can use control or knowledge source. The other thing that you want is the communication in the opposite direction. You want the communication of the repository telling the student or the professor that there is a new data. And that happened with the observer pattern. Something that you can do, a good solution, is if you already have observable the repository, the easy way to connect the repository with the other two is making this also observers. So the data is in the central place in the Blackboard, and you have these observers, the control, the knowledge source that are just checking when a new value arrives, and you know, this guy is the one that is going to calculate the lines, this guy is the one that is going to delete and update things, this guy is the one that is drawing things, but all the data in one place. So that have been my recommendation to the people that have asked. The connection between repository and control could be used like use the singleton and use the observer pattern. That is the easy one. Now, the other question is all about multi-threading. Do I need to implement multi-threading? The answer is depending on your solution for the shortest path. If you are implementing a good algorithm for the shortest path, for the distance between 2 points, if you have some good computational ideas here for calculating or keeping track of the shortest point to a particular new one, probably you can work without threads. Probably your program could be used enough using the observer, because when this guy observes something, he's going to insert quickly a new line. The reaction is going to be immediately. Nothing is going to happen with the graphical user interface. The user is not going to notice that something is being calculated, using the examples that we reviewed before. However, if you are doing the calculation of the shortest path in a way that is not optimal, for instance, you have 2 for loops, one inside of the other, and inside of that you have an if condition, and you're comparing all the dots with the new one, that could be a brute force approach. That is okay, but that is going to be very, very slow. And if you do that, then this guy is going to consume a lot of time, and the view is going to suffer for that. You're going to notice that your view sometimes do not respond to the clicks because the computer is busy here doing calculations or doing something. In those scenarios, just because you have this slow implementation or not optimal implementation of the calculation of the distance, my advice is you can go and implement multi-threading. Multi-threading, the easy solution, runnable, and you just make those two runnable. And the tricky part is use the method sleep. Put your threads to sleeps. Doesn't matter how long, but always, always, always inside of loops. If you have these 2 for loops, as I described before, a loop inside of a loop with an if condition, be sure to put a sleep at least inside of the loop that is outside. So at least every time that you complete a number of calculations, the system, the thread, go to sleep, and that is going to allow the view to work. So you need to use this one and probably implement runnable, but it's depending of the experience that you're having with your implementation. It's depending of how good, optimal is the implementation for you to search for the shortest path. So those are the questions that I have been receiving by email. Hopefully this helped you to complete your software. Again, you still have time, just complete this. That's it. I mean, exactly what I mentioned before. Control and knowledge source, observe. Good. Okay, so moving forward. That is regarding of the assignment. Hopefully you finish. My plan is to ask you for a last assignment, one more. So remember, more assignments we complete, less points that each assignment is going to value, because we have 25% for the assignments. So 25 divided by the number of assignments. So hopefully we can do one more, which means the individual value of the individual assignments is going to be a little bit smaller. Good. Share me the scenario, please. Okay, I have a question in the chat, a private question. If you implement your own observer pattern, you need to show that in your class diagram. Yes. If the classes are yours, you need to include the class and all the methods and attributes. Yep, we are going to expect that. Everything. If you use classes from the library, use the names, it's fine. But if you're telling me that it's your class, that you have a class observer and you have a class observable, it should be complete. Any reason? I could be concerned about why you are implementing those classes if they already exist. But well, if for any reason you implement your own classes, they should be complete in the class diagram and all the connections should be shown. The refresh, good question. You should refresh immediately, because that is one of the things that the Blackboard is going to help you. If you implement this correctly, and you have this implementation of the view is an observer of the data, something that you should agree with me is in any moment that the data change, just because this one is an observer, whatever is on the screen is going to change. If what you have is that this guy update only when I make a click, you do not have this observer, because you're reacting or repainting for the listener action, for the click, not for the action of calling update from here, notifying all the observers. So it should update immediately, because that is showing me that the observer observable is fully implemented. Good. It is not mandatory to implement any particular class. I am not asking you like a programming assignment, telling you a checklist of what to do. However, my request is do your best with your software design skills, with the things that we have reviewed, from refinement, information hiding, and so on, patterns, both design and architecture. If you review that, hopefully you will agree with me that you need a data structure to handle the data. From your data structure courses, hopefully you agree that the data structure that is being used here is a graph. And I think you have in your notes several different examples of how to implement a data structure graph. And you can use that here. So I am not telling you that it's mandatory to have the class graph, but it's a pretty good idea. Review your data structure notes and you will follow up with this idea. What is a graph in terms of data structures? This collection of nodes and edge, and it's exactly the same thing that you need here. It's kind of your memory, your data, and it's what you should use to draw, and it's what you should use to do calculations. So I recommend you to have this graph data structure. Good. Okay, so this is for the project. Again, the data structure and the process of the data in two different threads. The student calculating lines and the professor, the control, calculating this delete and reconnect. Hopefully you can finish that in a couple of hours, at least today, submit. Good. So moving forward. Next, I asked you to read these two papers after Garland architecture. I asked you to read about frameworks. Oh, very good question. I received this question about where to start the thread. Let's assume that you made this control and knowledge source threads, right? Where should you start them? Where in your program did you create the object control and call start? Where do you create student knowledge source and call start? Where should that happen? Any idea? Okay, I will agree with that. The main. Why the main? Because remember, the main is the place, the main is the leader, the main is the one that create the objects and put the objects to work. That is what you expect to have in the main. Create something, put that something to work. In particular, for the control, for the knowledge source, those two objects are going to be alive for the full period of life of the software, right? I mean, while the software is running, always, this knowledge source is going to be running. Also, the control is going to be running. They are core part of the system. The best place to create them and put them to work could be in the main. So in the main, you create the control, you create the knowledge source, you are going to create your view, or the main is going to be the view itself, depending on what you are doing. So all the actors are going to be there in the main, and then they go to work. Usually, my recommendation in the listeners, the controller, in the controller, you create objects if those objects are going to have a short life. If there is an object that is going to be born, do something, and then it's going to disappear, it could be okay that those kind of objects with a short life are born in the controller and do something and disappear. But if the object is going to be alive for the full life of the software, like this case, I would recommend the main, because the main is the place in which you are going to go and search for those kind of objects. So my recommendation, the object exists from the main. When you call the listener, the mouse click, the only thing that you do is use those objects. And as I mentioned before, my recommendation is the listeners, these guys, the mouse click. The ideal thing is the mouse click. The only thing that is going to do is to put data in the repository. Think about it. The click is going to put in the Blackboard a new X and a new Y, a new dot. When the dot arrives here, this guy is observing, so it's going to do something. This guy is observing, is going to do something. This guy is observing, is going to do something. So everything starts because this one put data in the Blackboard. When the data arrives to the Blackboard, other people start working. You do not need to call from the listener other elements. They are going to work because of the Blackboard. Okay. So the idea, remember, is to avoid connections, to have a small number of connections. A small number of connections also is going to represent few lines of code. You remember the relationship between the blueprint and the implementation. So clean the blueprint also is going to be clean coding most of the time. So take advantage of the repository being a singleton. Anyone can call it. Take advantage of the repository being observable. These three items, the view, the control, the student can be observing and therefore working. You will need some flags for sure. Some variables that you can put in the repository, like iStatus. If you remember the state machine things, the state machine diagrams, you need to think about what is the status of the data. Is a new data? If the data is new, it's a dot that you use insert. The first one that need to work is the student, because you need to create a new line, right? And then maybe you calculate the line and change the state. And then the professor can start working because you need to check that there are no points with 5 lines. And after that, maybe you can call or you can change the state, and now everything is ready to be dropped and the view can work, right? So it's like different states with the same data. You can control the order about who do what first. But use an advice, you can find several different ways to implement this. But do not communicate professor and student. Do not communicate control and knowledge source directly. There are no connections between these classes. There are no connection between these classes. And that's it. Okay, moving forward. We need to talk about frameworks. You read a paper, and the question that I have for you, and a question that is going to be in your exam, is what is a framework? In particular, I am going to ask if you can help me, what is the difference between a framework, an API, and a library? Because those are three concepts that we use in software, right? We have the Java API, or we have some libraries, or we have a framework. Do we understand the difference between those three? Can someone help me to guess the difference between, I am going to use two only first. So framework, library. What is the difference? A collection of components. A framework is a collection of components, yes or no? A library is a collection of components, yes or no? For both, the answer is going to be, yeah. Components, I am talking about packages, classes, things like that in object-oriented. In a framework, you're going to find classes or packages that you're going to import, classes that you're going to use to call methods, to inherit, to create variables, whatever. You have those components. A framework is going to give you components. A library is going to give you components. Kind of. I like that part. Everything that you have in a library is also going to be in a framework. If these are the libraries, or those are the concept of library, the frameworks are something more. Any definition that you can give me for a library is going to apply also to the framework. But the frameworks have something else, something that the libraries do not have. What is that? In one word, and you notice this, inversion of control. Depending on the libraries that you're using, you can create an entire system with a particular library or with a particular collection of libraries. You can create a particular system with a framework. The big difference between what you call a framework and what you call a library is inversion of control. A framework is going to apply inversion of control. A library is not going to do that. What are you talking about, inversion of control? What is that? The difference between a library and a framework is who is going to create the main, who is going to create the public static void main. If you are doing the main, if you are the ones responsible from the execution of the program from the beginning to the end. Whatever you are using are used libraries. Libraries. Because you have the control. Example. Yeah, example. Maybe you are working with Java. Java is the platform, the virtual machine, used for the example. And you are doing a program. If your program is the one with the main, all these things that you use in Java, the collection, remember all these packages with data structure, or you're working with sockets, Java.NET, or you are working with something for machine learning. If you are responsible for the main, if you have these calling methods here, or inheriting from here, or creating variables from here, this is a library, this is a library, this is a library. You go and use the components. Libraries. That is the definition. Okay. Frameworks. The frameworks. The big difference and the definition of this inversion of control is, yeah, you're going to create your application, but you are going to give the control to the framework in some point. In some point, you will not know what your program is doing because you are not the ones controlling the execution. You will develop software. You will develop, provide methods and variables and so on. But the execution is not in your hands. You do not specify what is going to happen next. If you do something like that, even in Java, if you provide source code, but your source code needs something else in order to run, and you do not know what is happening inside of that something else, what you're using is a framework, not a library, something more powerful. Talking about Java, are you familiar with that? Servlet. Java for backend developing. Yes or no? Probably not. Okay. Okay, yes. At least 1 yes. Tell me. Okay, 2 yes. Good. Servlet. You are doing a program in Java, and that program in Java is going to be the backend of web application. Is running in a server. Do you create a main there? You do your program, it's Java. You do inheritance and you create variables and you use libraries, but you create the main. And the answer is no. You create some methods. Do post, do get. Who is going to call those methods? Someone. Someone inside of the framework. The framework have the control, not you. Okay, Professor, I have no idea what is this servlet backend developing. Okay, a more trivial example. Have you done graphical user interfaces in Java? You could tell me, we create the main. You create the main, and the only thing that you do in the main is to create an object from your main class. And after you do something like set visible true, Remember? Do you have the control? Do you specify in your source code what is the next thing to happen? Do you call your listeners? After you put set visible true, you do not have the control. After you put set visible true, what happened is that the software entered in an infinite loop. And that infinite loop is just waiting for something to happen. Do you program the infinite loop? No. What is happening? What is happening is that you are using swing plus AWT. Swing and AWT, they are libraries. They cover everything that you notice in the libraries. They are components and so on. But they also apply inversion of control. Is the graphical user interfaces framework in Java. Not only libraries. And we're talking about Java and we're talking about frameworks and libraries. Libraries, if you use them, but you have the control. Frameworks, the key idea, when you give up the control to someone else, to the framework. Another example in Java in which you lost the control, besides the graphical user interfaces and the backend developing servlets. Do you remember another example in which you do not know what is going to happen? Someone else have the control. You can explain to me how does it work, the multi-threading framework in Java? It doesn't matter if you're doing runnable or thread classes. You create a class, and that class create objects, and you call the method start. What happens when you call the method start? You give up the control. Because the last thing that you do is dot start. And from that moment on, the control, what is going to happen next is not yours, is someone else. Someone take the control, and that someone is going to call your run method or whatever. It's going to call software that you create, but you do not know when or how. There are some rules, obviously, but that is the main difference when you talk about framework and libraries, inversion of control. Usually, because Java have mostly libraries, we use the Java libraries, or more fancy, the Java API. You can notice the API name is basically the inclusion of both or any of the others frameworks, libraries, frameworks. Only this one, or maybe a combination of both, and you can be talking about application programming interface. Makes sense? So for your exam, the main thing to remember, inversion of control. And inversion of control is something that always happens when you create graphical user interfaces. You give up the control. Text application, you have the control. Multi-threading, you give up the control. Web developing, you give up the control. Why? Because you are expecting for a connection from the outside. Any language, platform, whatever that you use to create web applications in the server side, you are giving up the control because there is not a main that you put there. Is events. You like the graphical user interface, but here is with connections. Anyway, so frameworks and libraries, a concept to remember for your exam. Now, moving forward, everything that we have been reviewing is this idea of the blueprint as one very important part of the software developing. The blueprint shows us the quality. The blueprint can be transformed to source code. What happens when we put together a blueprint, a good blueprint, and a good set of libraries, and frameworks. If we put this together, what we achieve, what we can have is it is possible to implement software from scratch, use drawing diagrams, and trusting in a framework for the execution. And if you do that, input a blueprint, output a piece of software with a lot of help from a particular framework, what we are doing, what you are doing is model-driven development. And I want to talk about that as our last topic. Model-driven development. As I summarized before, your input, the diagram, your output, a piece of software, complete software with the support of a framework. A framework, several libraries, plus the idea that you're going to load the control, inversion of control. So you could worry about the main or not, depending on what you're doing. Advantage of that. Number one, probably the most important, time. When you know how to do a blueprint, when you know how to put in a blueprint all the important parts of the software, is faster to do the blueprint, to draw something, that write the code. Moreover, if I have the support that any library that I could need is going to be added automatically instead of the developer doing that manually, that is going to save time. Model-driven development. One of the main advantages, the one that is going to bring first, time. You can develop something very, very fast. And I am going to show you an example of it. So, second, something that is key is the quality. And the quality, I am going to talk more about the testing part. When you are doing software manually, when humans are developing software, humans can make mistakes. And therefore, you need to test everything that a human do. When you create software, when you ask the computer to create the software and using as an input your diagram, something that you can be sure is whatever you put in the diagram, the computer is going to put in the product. Your testing is more about the functionalities that you put in the diagram, is more about things that are specific to the software, instead of be testing things that obviously should work. For instance, if you're using patterns, you need to test that you implement correctly the observer pattern. What if the computer implement the observer pattern for you? You can ignore the testing on all the things that are patterns and use a standard procedure because you know that there are no human involvement. The computer created, the computer know about it. You do not need to test that. You can use your time for testing the functionalities, the original things, not the things that are standard procedure. Again, I am going to show you an example, but those two things, time and testing, are the key ideas that support model-driven development. Okay, good. So whatever. What we are talking about is, okay, option number one, the common idea of developing is doing programming, and doing programming is all these people adding lines of code. What we are talking about here is, forget about that, do a diagram, do a model. That model can be a diagram or some other kind of model. Provide that model to the computer, and something is going to move from this to the software that you can develop with humans. If I show you this picture, the most important thing that you're thinking right now is, what is this? This machine, this thing that is going to take as an input the model and it's going to give us the software. That is the important thing, right? Yeah. What is going to happen is, if we have that thing, then as a developers, what you are going to do is to create a model. It could be a UML class diagram, yes. but it's not the only option. Any representation model of the software, I am going to talk about it, but you create a model. And that thing is going to create code from the model. And then you can do your testing. And if something is wrong or is not what you want, you go back and the thing that you updated your model. And then you create code and do the testing, and you can be here for a while. When you have something that do the thing that you want, you can move forward and customize your code. Customization. Adding the functionality. In the software that you are doing right now, in your project, you are struggling to program, to implement the Blackboard pattern. Just imagine that you have everything done. The Blackboard, the observer, the listeners, the threads, everything is done. And the only thing that you need to add is the data structure for the graph and these loops to find the shortest path. But you do not care about all the other parts, the communication, who is going to do the draw, how this information is going to come here. What if you have all the structure and you can just worry about complete this method, complete this method, complete this method. Put the lines here, here, and here for the computational data structure and the computational algorithm that is particular for your software. That is what we call here customization. Just adding the things that are particular to that software, but all the other things, all the structure done automatically from the model. Okay, the process looks like easy. The question is still the same, like this machine that you showed me in the picture and this idea of create code, who is going to do that? A piece of software, a program. You'd like a compiler, do the translation from your source code to the machine code or whatever. There are software that can translate from your model to source code. And moreover, that can add libraries. There are different options. One of them, a common one, a famous one, probably the most useful, comes from those guys. Hopefully it is clear for everyone. Eclipse is not a software, it's not an IDE. There are several different products under the umbrella of Eclipse, right? One of them, only one, is the IDE that some of you can be using. But there are several different tools, frameworks, libraries that Eclipse foundations have. And you can go to the web and check a list of all the things that they do. One of them, besides the IDE, is this one. Eclipse Modeling Framework. There are going to be libraries there, yeah, but it's a framework. It's going to be an inversion of control. And it's from Eclipse. And it's something related with modeling, models. This is a product from this company, and this product is going to do all this process that I described for you. Okay, so good news is open source. Good news is available for free. You can get, and we can play with the tool. One of the reasons because I select this to show you, because you can get it and do homework later using the tool. So, but before using the tool, let's learn what to do. Eclipse Modeling Framework, as I mentioned, the 4 steps. We're going to do those 4 steps for a project. Step number 1. Well, before the step number 1, my step number 0. The first thing that you need to do this is to get the tool. Get the tool. So for the tool, what you're going to do is to go to the web page. I am going to give you the link and get the tool, install the tool in your computers. It's available for Windows and Mac without a problem. What are you going to get? What you're going to get is this. These important things. Number 1 is a framework. is a framework and it has libraries inside. Libraries inside, in particular, this, and this are libraries that you're going to find in every single product that comes from Eclipse. If you have run any other product besides the IDE, you will notice that all the products developed by this group looks the same, and they look the same because they have their own widgets. And those widgets are going to be available for you to work. So just to give you an idea, you have all these things. The product that you're going to run, the product that you're going to create is going to look like the Eclipse IDE because of libraries. Good. The philosophy that they follow is this is a framework, these are libraries, and you can connect more things as plugins. You can develop your own software and just connect your software to what they already have, and they call it a plugin. Okay, nothing fancy here. What we are going to do, what you are going to do, according with this is, this here is not the IDE for programming, the one that you use to program with Java. This one is the IDE for EMF. Inside of the IDE, you are going to develop your model, a UML diagram. That diagram is going to be saved to a file. That file is an XML file, in particular, XMI file. That one is going to go to a tool that is going to create classes, methods, packages in Java. And this one is going to be your product, a piece of software. Moreover, in that piece of software, you can use all the graphical user elements, tabs, text areas, frames that already exist in Eclipse. When you run this project, what you're going to have is this one. And that one looks like the Eclipse IDE, looks like the Eclipse EMF, but this one is going to be your application, the software that you are doing. What I want you to notice when you run this in your computers is you have exactly the same environment for developing software with code, for developing software with diagrams. Moreover, your software, when you run that software, the same elements that you notice in the environment that you use to create the software is there supporting the execution of the software. The same framework and libraries. Okay, 1, 2, 3. This looks very simple. Let's do it, right? In order to do this, step number 1, your homework. You can do this homework tomorrow or during the weekend. So I am going to give you these slides so you can follow. Number 1, you go to that URL, you go to the URL, and you need to get these two. Again, in the URL, you're going to notice all the different tools that are available from the Eclipse Foundation. This is the one that we need. EMF, Eclipse Modeling Tools. You get that one, and you notice all the possible options. So whatever computer you have is going to work. You get that, install in your computer, move forward. After you complete the installation process, very simple. You already are familiar with that. You are going to have this tool running. It's going to look like this. The only thing, because I am showing you the picture, and the only thing that I want you to notice is if you ask for the about, that is what you should read. Eclipse Modeling Tools, which includes the Eclipse Modeling Framework, is running the Eclipse Modeling Framework. Please be sure to validate that you install this. I am not asking you to install the Eclipse IDE. This is not the Eclipse IDE that you use to write source code. This is a different tool from Eclipse. So be sure to check that you have that installed in your computers. And next, we can start working. And we can start working, and here we start with the step number 1. Step number 1, the input. We need to provide a model, right? The model is going to be the one that we use to create the software. The model. 2 options. Option number 1, you can draw a UML diagram. And you can draw a UML diagram like this. You know UML diagrams. We have been using UML diagrams. You can use that UML diagram. And you understand the meaning of everything, right? So you can create, I am going to follow this example with a course, and students, and a computer, and the relationship. It could be possible to draw the diagram. However, it is not mandatory. It is not mandatory. Why? Because to be honest, drawing the diagram could be some kind of overwhelming. It's a lot of work to draw the diagrams and to play with this idea of the lines do not cross in each other. And in some point you have a big diagram and well, you need to organize the structure in order to understand what is happening, right? So it is possible to use the diagram if you like that, but there is a second option. A second option. The second option is you can provide a description of the diagram to the tool. A description. Let me see if I can explain this quickly. The only thing that you need to explain to the tool is that you have a new project, a new diagram, a new project. This is the name of my project. The name, I am using this, my model. You can put my project, my work, my homework, is a name, whatever name you want to use. Usually when you are creating a project for programming. Next, I need to tell the system that that project have 3 classes. It's going to be the same classes, abstract classes, or interfaces. Those are going to be things that we can configure later. But how many rectangles? I have 3, right? 1, 2, 3. And as you can imagine, the graphical interface for this, the system, is going to be a place in which you can do right click, and you're going to have a menu, and in the menu you can select new class, and that new class is going to create this input. It's going to ask you for the name, you put that name again and again, and you can create 1, 2, 3 classes. Use click, right click, name, right click, name, right click, name. Exactly the same that when you're creating source code. With the only difference that when you're creating source code, every time that you create a class is a new text editor that open, right? A new tab. Here, it is going to be the line with the name. Inside of each class, you can make a click and you can insert new attributes. New attributes like the name or name, GPA, whatever. Attributes, variables. Obviously, when you insert a new variable, it's going to ask you for the data type. The data type is something that you put in the diagram. So classes and attributes. So far, exactly the same that you have in programming. Now, what about the methods? This is for creating the structure of your program. This is going to create by default constructors, getters, and setters to strings. That's it. Any other particular method is something that is part of the customization. It's something that you can add later. It's something that you do not put here. Because the computer, this system, is not going to do anything with your methods. Your methods are for you to customize, for you to complete. The only thing that this is going to create is the default methods, you know, setters, getters, constructors, and others that I am going to show you. But the only thing that we need to include here is the variables. The variables, obviously, with the variables, we are talking also about composition and aggregation. They are going to be there, but in a particular way. This relationship here is something that we are going to include like this. I am going to tell the computer, add attribute, I add an attribute, or add a relationship, You want to add a relationship. Click here, add a relationship. Okay, a new relationship. What is going to be the name of the relationship? This is the name. And it's going to be connected with which class? Which this one. Here, a relationship. The name, this one. And it's going to be connected with who? This one. If you're familiar with a database design, with creating a database, if you have used tools for that, this is more or less the same idea. A table connected with another table, and these relationships like the foreign keys kind of idea, and the attributes like the attributes of the table, the columns. Following this idea, you can input this diagram without worry about the drawing. But again, both options are available. Good. I have my diagram. I input the diagram in the tool. Next. The diagram, in order to do this is the summary. What you need to do, and I am giving you these slides for you to practice, is you are here. Step number 1 is to do this. Go to File, New, Other, Empty Project. Like create a new project in your IDE. Step number 2, next, provide some input, click Finish. This is how to create a project. This, how to create a new model. Inside of my project, a new model. That new model is going to be an Eclipse model. I am going to talk more about it, but I need a new model, an Eclipse model. The Eclipse is this thing that I show you here. So a new of those. I do not want to draw. I want just to input the tree. Okay. After you do that, what you're going to have is something like this. And something like this here is the place in which you can start working. Start working, as I mentioned, right click here. You're going to have a menu, add a new class, right click to the class, add a new attribute, right click, add a new relationship. Here is the place in which you capture your model. Your model in particular, using the Eclipse, the tree representation, is going to be there. That is step 1, input the model. For every single thing that you input, an attribute, a class, a relationship, they have parameters. They have particular values that you need to configure. In this space, you're going to notice those parameters, those values that need to be configured. Among others, obviously, the name for everything. For the relationships, you are going to notice there the multiplicity. You can specify there, is a relationship 1-to-1, many-to-one, one-to-many, and so on. Those are going to be there. I want you to notice and take a look at these elements, and we're going to talk more about them in the next lecture. So create the model. Each element in the model have some particular values. I am giving you here values that you need to input for my example. When you have the model inside, it's going to look like this. This is the one that I showed you before. And as you notice, just like in any Eclipse project, you select one, and that one, the select one, is the one that is going to show you the attributes. Okay, that one is use an attribute, brand is a string. You're going to notice this letter I before. We're going to talk about it. And then all the different attributes, features connected with that one that you can edit. My model. Very simple. Next. When I have a model, this is kind of your menus. This thing is equivalent to this one. Use the same. An important thing here is for the multiplicity. You're going to notice that something that this tool do is you're going to have these minus ones in the multiplicity thing, like that. -1 represents many. -1 represents what you usually put as an asterisk in the class diagram. So just to give you the note, do not be worried about that. -1, nothing is wrong, is the representation of many. Because any other number, 1, 2, 3, 4, 10, is going to represent a particular amount, a particular number of elements. -1 represents many, and in that way, this field is a numeric field instead of something like a string or a character in which you can put the asterisk. So something that they did to facilitate the process internally. -1 is many. Okay, so my model. If you continue doing this, you can create the other part, and you will notice the other relationship that we are going to create there. The specifications about how to create a relationship here. My homework for you, follow these slides and create this. I need you to be proficient with this. I need you to do this so we can have a discussion about what is happening, but with you having the experience of creating this. Be aware of, okay, I did it. I create a model, and then I click compile, and I have the output, and we're going to review the output. So step number 2, in the first part, creating the model, the other relationship with this instruction, selecting those data types, and it's going to look like the picture that I am showing you. So far, relationships and the classes and the attributes. Until this point, you are done with the model, and the next thing is to create source code. And we're going to create source code and review the source code in the next lecture. So far, questions? Don't worry about the deadline. Probably I am going to ask you to do the assignment next lecture. So I am going to give you, as usual, I am going to try to give you, as usual, a week to work. But this is an assignment that you can finish in a couple of hours. But I am going to give you the week. Remember, we still have time because your exam is going to be the next week, Wednesday, but we still have another week to work. The graders are going to be grading things. So my expectation is to talk about this in the next lecture and give you a week to work, but hopefully you can finish before that week so the graders can complete the grading and you can have your final grade completed. But a week is the expectation. Good. So if you have the time to do this, to create the model, basically you are moving forward with that homework that I am going to ask you to do. My homework is going to be literally asking you to complete a model and to create the source code for that model and to customize that model for a small things to do. So if you are able to follow my example, having the tool and doing the things that I am giving you in the slides, and I am going to continue to do that, practically you are doing the homework during the lecture. My goal, asking you to do this homework, is number one, obviously give you some practical knowledge of this topic, but second, adding one more assignment and therefore reduce the points for the other assignments. This is an easy one. Hopefully everyone is going to receive a good grade here, and that can minimize the impact of previous assignments in which maybe you do not perform 100% well. Hardest assignments, the one that include programming. So those two things give you the opportunity for one more and give you practical knowledge of model-driven developing. So homework, do this, do this, do this, and this, and this, and this, and get the tool from this web page. That is your homework. Hopefully you can do it, not today because today you are working your assignment, but maybe during the weekend. Good. Very good point. Thank you for that. Almost forget. Guys, it's going to open your last quiz. Another thing that I want to do is to add one more quiz so I can reduce the points in all the quizzes. Remember, 20% all your quizzes. So I am adding one last quiz so we can divide those 25 points between more quizzes. Today, your last quiz is going to open. You have until midnight to complete the quiz. The topic for the quiz, 3 things. Number 1, design patterns, architectural patterns, and class diagrams, in particular, relationship between objects. So the quiz is going to ask you about observer, adapter, decorator, bridge, and so on. It's going to ask you about model view controller, Blackboard, client server. And it's going to ask you something like, hey, this source code, which of the following is the correct diagram for that source code? Just like that. Source code, several classes, and the question is, which of the class diagrams below, A, B, C, D, is the one that corresponds to that source code? So a very good idea to review patterns, design patterns, architectural patterns, and if you need it, also to review composition, aggregation, and association. Be sure that you know which is the source code equivalent to those 3. Inheritance, if you need also, because you're going to have questions about that. And that's it. That is going to be your last quiz. Any question, guys? Good. So see you next lecture for the final review. Thank you.